Okay, so this is day 2 on the final review. Also, you can use a full sheet of computer paper on the front side and back side with anything you want during the final. So you can have your final and a cheat sheet, computer paper front and back. You can write down anything you want on it. So 24 is where we're starting. Draw the Lewis structure for F2. In order to draw the Lewis dot structure is what it's called. So you're gonna put dots around the element. So it's F2, so how many F's are we going to have to draw? 2. Okay, how many dots go around each fluorine? You look at the periodic table. So the amount of dots, the Lewis dot structure shows the valence electrons. Valence electrons are the outermost shell. So there's 7 dots for everything in this family. 6, 5, 4, 3, and the other side's 2, 1. Okay, so here's fluorine. So how many dots does fluorine get? 7. So each one will get 7. Okay, and you're done. This does create a bond. That's 24. So now we're going to move on to 25. So it says draw the Lewis dot structure that represents the formation of an ionic compound MgF. Okay, so we have M, G, and F. And it's telling you it's ionic. Does ionic share or does it steal? It steals. Okay, if you had a choice between ionic and covalent, I should have given you your other option, because once you hear the word co, you know it's together. Okay, like cohabitate, you're living together with someone, okay? So cohabitate, they share, like 2 elements holding hands. Ionic, they take electrons from each other. So I always say they steal. So ionic, in the science world, you say it transfers. And then if you just want to write this down, this is something I would write on my cheat sheet. Covalent shares. Good job. Okay, so back to what it wants us to do. Magnesium has how many dots? It's fine, Mg. Yeah. Mg is right there. It gets 2 dots. And then fluorine, we already identified over here, gets 7 dots. It's right there. So 7 dots. So magnesium gets 2, 7. Yes, it is an ionic compound, but it's going to take one of these to get the octet. And by doing that, the fluorine then gets 8. So that's just showing you how it's stealing or transferring electrons to fill its shell up. It can only have a maximum of 8 in the outer shell. Number 26. Explain how to determine if something is ionic or molecular. Covalent is also known as molecular. So that covalent and molecular mean the same things if it ever asks you. Ionic is going to be a metal plus a non-metal. Covalent is non-metal plus non-metal. When are you going to use prefixes? Do you guys remember when we use like the di or mono, tri, tetra, penta? Is it ionic or covalent? Okay, the covalent bonds use the Greek numerical prefixes for numbers. And we're about to go over 1 through 5 on the other side. Let's go to the other side. Just a side note, if you want to add it on your cheat sheet, Ionic uses IDE. Just adds IDE to it. So like something like sodium fluoride, NaF. All it did was sodium, add the IDE. Or lithium bromide. Okay, those are ionic. You just add IDE. Okay, let's go to the other side. So with the information I gave you, I'm going to try to circle the ones I want you to do on your own. C, do by yourself. D, do by yourself. I'll tell you right now that 5 is penta. Don't ask me for the others. You can look it up in a textbook or your notes or a cell phone or a computer. 27, you can do on your own. 28, you can do on your own. Yes, you can do those on your own, but I did give you some information this morning. So you can write this down. So it says a single replacement only has, these are just little hints. These are my tricks on how I can tell if you don't really learn the concept very well. You're only gonna have 3 elements before the arrow. That's single replacement. If it's double replacement, you have 4 elements before that arrow. Synthesis means you're making something. So A plus B, after the arrow, you have AB. They joined. Decomposition, something broke up, okay? So it's a breakup. A, B, and we're together before the arrow. After the arrow, they are now separated. Combustion, the product for combustion, what is that?
H2O.
H2O and CO2. Always, always, always. Even if you have no idea what the reactants are and you see that on the product side, you already know it's going to be combustion. Yep, the same thing. It's always going to have the same product, salt and water. And I gave you number 34. This is an example of an acid-base reaction, which is called neutralization. So I'll let you get that down. F is neutralization. An acid-base reaction, acid plus a base, gives you salt and water.
This is SOH plus H2O.
Which one?
Product equals S.
Yeah, salt. Sorry, that says salt.
Oh.
This says salt and water.
Or 28, what does it mean by give the formula?
28? Oh, okay, let me help you with that. I gave you an example. Give the formula for the following. Sodium sulfide. So it ended in IDE. So that tells me it's already ionic. So Na has a charge of +1. That's a good question because I need to show you charges. Okay, so sodium has a charge of +1 and sulfur -2. I got that because if you look at the periodic table, you can write these on your table right now. Here's sodium. The charge for everything in this first column is +1. Everything in this column is +2. So you might want to write that on your periodic table. Then we start from this side. Non-metals are negative. So everything here is -1, -2, -3, -4. Aluminum is +3. That's the common one to know. Okay, so like I said, sodium is +1. Sulfur is -2, but you have to butterfly them. So when you're done butterflying them, this is your final chemical formula. This is the correct formula. So no, to do these, you do have to write down the charges, then butterfly them. So follow that example. Go to this side. 35, an active metal and a halogen group form a salt. So you can also write that on your periodic table. Halogens are 17, family 17. You can write halogens and then I just put a dash salt. It might ask you something about that. Family 17. Number 36, in order to figure that out, you had to use activity series. The activity series is this side of the periodic table. And you have to see if something can replace something. Like, is magnesium stronger than aluminum? Then a reaction will occur. But what if it's asking, can sodium replace potassium? No, because sodium's lower on the list. So as we looked at these, just so if you turn your periodic table to the activity series side, so you'll know how to use it. So I'm looking at the reactants, I'm looking at the products. Okay, H was with Cl, and now Mg was with Cl. So Mg replaced H, right? H is no longer with Cl. So can Mg, which is magnesium, replace hydrogen?
No.
So I go over here. Here's magnesium, and hydrogen's down here. So can magnesium replace hydrogen?
Yeah.
Yes, because it's higher. So that's why I put a star here, because yes, that reaction could occur. Because the question's asking you which one will not occur. So that's how you use that chart. You can cross off entirely the questions at the bottom. Those were removed. Let me see how much I've assigned you already. What did we start at? We started at 24? And just a moment. Yes. Yeah, for today. Yeah, today. Okay, we'll get down number 46. Hopefully you're getting down this one, and then you are going to be responsible for the ones we didn't do. Every class period is sort of at a little different period, so get to 47 today. If you need the example, S, because it's CS2. The way that this is the number given in the problem. This is what you need. This unit has to match this unit. So this is the only number that always changes. If it's in grams, where do we find grams? Yes. Grams, or you need grams, go to periodic table.